Hello and welcome to a new video. This is for pre-algebra using the Math You See curriculum. We're on lesson 23, moving right along. It's been fun. It's going to keep being fun. And as we move along here, we're going to talk this lesson about a concept called polynomials. And that's a long and possibly intimidating word that basically is used to describe when we have x's and numbers and added and subtracted together. Poly is a prefix that means many. You might be able to think of like polygon, which we actually talked about fairly recently. It means many sides. I feel like there are other things that we thought of in class that maybe start with poly. But it just means that polynomial means that we could have many x's basically. And that's kind of the gist of it. We also have some more specific names that we can give based on how many terms we have, because as we go through algebra, we'll notice that things that have a similar number of terms, actually we can kind of do similar things too. It's kind of weird to talk about now, but it's a fairly standard thing that we do where we name these by how many terms they have. And by the way, whenever I say terms, here's what I'm talking about. If I use this example of 2x squared plus 5x minus 9, I can split this up actually into three terms. I can say I have a 2x squared, I have a plus 5x, and I have a minus 9. That's how we would break it up into what we call terms, because each of those things affects what we've got going on differently. Like having 2x squared, well, if x is really a number, then we'd have to square it and times it by 2. That's a thing that is kind of a unit together. It's kind of weird, I'm going to be honest, to try to explain it right now in pre-algebra, or even ever, I guess. But polynomials is something that we end up being fascinated by in algebra. So a polynomial with just one term is called a monomial. So mono is a prefix that means one. You can think of words like monotone or monorail or monopoly. All of those have to do with having one of something. And so a monomial is a polynomial that just has one term. A polynomial with two terms is called a binomial. So you can think of words that start with bi, that would be like bicycle means two, right? A polynomial with three terms is called a trinomial. So tri, of course, is a prefix that means three. So things like tricycle, triangle, things like that. And then algebra is us basically doing arithmetic like we normally do, but in base x instead of base 10. Now that's kind of weird because I don't know how much you know about base systems. So we are a base 10 society because we count to 10 and then we carry. So you do when you do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you don't have another number, you carry and make it 10, that we have 10 numbers. So we're a base 10 society. And every time we get 10 of something, we add a new place value. So saying that algebra is us doing this but with base x helps us think about this. If you've been doing Math You See for a while, or if you've just been using manipulatives for a while, we have these like unit blocks that we can use whenever we're talking about place value with a base of 10, where you'll have, I'll actually go ahead and scroll down. You'll have maybe these three kinds of unit blocks. So this would be 100 block because it is usually 10 by 10. This is a tens block. You don't need to write this down if you're writing down notes. And this is a ones block. So we actually can use this to represent the idea of polynomials by basically saying, well, the ones block is still going to be ones, but our tens block is now going to be, is going to represent how many x's we have. And then our hundreds block is going to represent how many x squareds we have. And so we actually can kind of build these polynomials we're going to be talking about using our blocks. We just would ignore the fact that a tens block has 10, because basically we're saying that we don't know what x is. It could be 10, or it could be 3, or it could be just whatever it wants. And the reason then I think makes more sense why x squared is something completely different from x, because x squared, we're talking about having not just x, but x times x, which gives us something much bigger than just having x, right? So I think this representation is neat in that it shows us why we can't combine x squared, x, and then just a regular number. It also can help you see that this is very similar to what we do with place value and adding. If you have multiple x squareds, you can add them together and say how many x squareds you have. If you have multiple x's, you can add those together. If you have multiple ones, you can add those together. And what we're doing in this lesson, aside from the fact that there's some vocabulary and kind of concept things that are going to be on the first page of your workbook, what we're really wanting to add to our skill box is adding polynomials. So that's going to look like these two examples here. And I think this is going to be fairly straightforward, because if we just took out the x squareds in these two problems, this is actually something we've already talked about, that we can add x's together and we can add numbers together and simplify something. We did it around the same time as like distributive property when we went over that. So all we're really like introducing here is that we can also do this with x squareds. That x squareds wouldn't add with x's, but x squareds can add with other x squareds. So if we set it up this way, like we wouldn't actually have to set it up this way. We could set up this so that the polynomials were like next to each other. But this is one of the easiest ways to write it and to actually work out what it is, where just like we do when we add numbers, hang on, like if you add these numbers together, right, don't you line them up by place value? Of course you do. So it's the same kind of concept here of we're lining these up by their like terms, by their place values. But we don't actually end up ever carrying whenever we do this with polynomials. So you could actually write things down from left to right or from right to left, depending on like your preference. So for instance, I could do -7 plus 12, and that would be a +5. So I'm going to write +5. And that's a little different than what we do with addition, right? Because that we don't normally write the plus there. But we're going to need to do that to show whether we're adding or subtracting these things together. 5x plus a -3x or 5x minus 3x would be 2x. And then 2x squared plus 4x squared would be 6x squared. And that's it. You can't combine these x's together because this one is an x squared and this one has an x. So this would be like us saying that we have 6 of these boxes plus 2 of these like rulers. Well, you can't add boxes and rulers together, especially if you don't know how big either of these things are. And so that's why this would just be our answer. We can't do anything else to it. So we're done. Try example 2, like pause the video if you need to. Try it so that you can see if you got the hang of it. Okay, so 11 plus 4 is a +15. -6x plus a -7x makes a more negative number, so a -13x. And then 5x squared minus 3x squared is 2x squared. And that's it. I do want to make one other comment, and that's that if you see something without a number in front of the x's, I want to remind you what that means. If I have x squared, I really mean 1x squared. Or if I have just x, I really mean 1x. Or we could do the same thing but have minuses, right? That if I have minus x squared, there would really be a 1 there. Minus x, there'd really be a 1 there. And that's because that's the only number that actually makes sense in that situation. Because if it was any other number, they would have had to tell us. If they meant 2x squared, they have to say 2. If they mean no x squared, like 0x squared, they wouldn't have put the x squared at all. So the fact that there is an x squared, but not a number in front, we just know automatically that it means that there's 1x squared. So I think that this all should hopefully be enough information for you to do lesson 23 in the Math UC Pre-Algebra workbook. And please give this video a thumbs up to say, hey, I like that you had this video, or I like this video, or I like you, or whatever. Because of the way YouTube work, it really helps me out if you like and if you are subscribed. You don't have to be subscribed forever, but you know, you could subscribe for now and then just forget that you're subscribed and stay subscribed forever. That would be fine too. And I'll see you in the next video. Bye.